Instruction Skills 16 is dealing with changing units of measure. And I'm not sure if we are just using standard units of measure or all of them. And before I get started, I want to look at that. So I'm looking in the textbook just to see what we're dealing with. Actually, it looks like we're doing all of them. So that will help me. Yes, okay. First thing I want to do is look at this margin example so that you get sort of a mental image of what we're trying to do here. 2.5 gallons could be represented as 10 quarts. Each gallon has 4 quarts, so you would have 4 quarts, 8 quarts, and then half a gallon would be 2 more. So 10 quarts or 40 cups. All of those are equivalent amounts. It just depends on the size of the container that you may have. So you could think of this as 2.5 gallons of water would fill up 10 quart containers or 40 cup containers. And that's the type of problem we're looking at on these 2 pages. So let's look at a story and see what we need to do to solve the problem. Jolene made 2.5 gallons of chicken soup for a lunch fundraiser. Which expression gives the total number of servings Jolene made? And they have broken this one down in number 5. 2.5, that's gallons, times 4 quarts times 4 cups would give you the correct answer. Changing from one unit to another unit. Each row of the table shows the same amount in different units. Example, 1 gallon is the same amount as 4 quarts. To change from one unit to another, first decide whether more or fewer of the new units are needed. If more are needed, you will multiply. If fewer are needed, you will divide. And here's a table that breaks this down. 1 gallon equals 4 quarts. 1 quart equals 4 cups. 1 cup equals 1 serving. And they're showing you that if you need more but smaller, you multiply. Fewer but larger, you will divide. And the answer they have done here, using the table, change 2.5 gallons to cups, which is the same as servings. Write the number of gallons, 2.5 gallons. Change gallons to quarts by multiplying by 4, and change quarts to cups, again by multiplying by 4. And that is your table capacity conversions. Now, I definitely understand the method they're using here, but this is not what I would do. I would do it this way, and you can absolutely choose what you like. You could even do it another way. As if it makes sense to you, use it as long as it gets you the answer. So what I am looking at is right here. I see that she has 2.5 gallons of soup, and we want to convert that into servings. Okay, so I know that 2.5 gallons, that's a lot of chicken soup. We want to know how many servings, and a serving is a cup. So everyone who attends the fundraiser gets a cup of soup. That is 1 serving. So we are trying to figure out this equation. 2.5 gallons equals how many cups? Okay, so what I would do, I have memorized my conversions this way. Actually, this is not the way I did it, but this is the way I taught it. I want you to think of this as 1 gallon. Okay, 1 gallon. If this were a stick figure, he would have one arm, another arm, one leg, and another leg. Okay, those are quarts. So there's a quart, here's a quart, here's a quart, and here's a quart. And I used to tell my students to give him a face so that you can equate this to a body. So here's the gallon man. Okay, so 1 gallon is the same as 4 quarts. That is one of our conversions. You need to memorize that. 1 gallon is 4 quarts. Same amount, just that quarts are smaller units. So maybe I have a gallon of lemonade and I want to divide that between 4 people. Each person would get a quart. All right, the next thing is to put in the elbow and the elbow and the knee and the knee. These are each a pint. So there's a pint, there's a pint, here's a pint, here's a pint, here's a pint. So how many pints are equal to 1 gallon? There are 8 of them. So 1 gallon could be expressed as 8 pints. Okay. Now, let's give the gallon man some fingers and toes. He does not have thumbs. He only has 4 fingers, and those are the cups. Here's another set of digits. No big toe, just 4. And here's 4. So a gallon has how many cups? One gallon has 16 cups. Okay, so in our problem, we know that a gallon of soup would serve 16 people. And that's how I would actually solve this, because I have memorized those. This is a visual that will help you to memorize those if you need it. But if you can just memorize things, memorize those conversions, and life will be a lot easier. Then once I know those, I can use a proportion to solve my problem. I want to convert gallons into servings, which are the same thing as cups. And I know that 1 gallon has 16 cups, and we have 2.5 gallons of soup. So I would be multiplying the peanut. 2.5 times 16 should be 40. Use your calculator if you need it. So that's 16 times 2.5 is 40. And remember, we always have to divide by what's not in the peanut. And that's going to give us an answer of 40. If you hear music, it will stop soon. I'm sorry. I'm always recording at night. So music is playing in the house, but it will stop. So 40 servings or 40 cups would be the answer to this problem. So however you choose to do these, that's okay. As long as you're getting the correct answer, it will work. All right, let's practice a little bit on page 45. And here is the first concept problem. Problem 1 refers to the table on page 44. So we need to look back to this table, and I will take a picture of it. Or you can think about your gallon man, if that analogy makes sense to you. Just helps you to visualize it in something that's familiar. Okay, Jamal expects 100 people will attend the school barbecue. If he allows 2 cups of punch per person, which expression tells the number of gallons of punch he should prepare? So we are going to turn, actually we're working the opposite way this time, aren't we? We have 100 people who are attending, and each person gets 2 cups. So I'm going to multiply 100 times 2 cups. And that tells me that I would need, or Jamal would need, 200 cups of punch. And then we need to convert that 200 cups back into gallons. So I'm going to use a proportion. Actually, let me look at what I have here. No, I'm going to solve it with the proportion, and then we'll look at those. So I am trying to convert cups into gallons. And if you envision the gallon man, remember his fingers and toes with no thumbs or big toes, there are 16 cups to a gallon, and we want to convert 200 cups. So at some point, we will have to divide 200, because remember, you multiply the peanut. So 1 times 200 is 200. And then you turn around and divide 200 by 16. And I'm going to go ahead and do that. 200 divided by 16. You all know that I hate concept problems. 12.5 gallons of punch. I would much rather just solve it than have to do this. But I have to do this. They don't give me a choice. But right here is what we need. We have what we need. 200 divided by 16 is the solution to this problem. And let me get that to highlight so you can see it. 200 divided by 16. So which of these answers matches what I've done there? Number 1 is out because there's no division. Number 2 has no division. Numbers 3, 4, and 5 do have division. So we need 200 divided by 16. This one is 100 divided by 4. That is not what I need. So that one comes out. Number 4, I do get the 200. All right? But it's not divided by 16. It's divided by 4. So that's not my answer. But look at this one. There's the 200. And here is the divided by 16. That's the one we want. Number 5 is the solution, is a solution to this problem. The way that I did it is also a solution to this problem. And you can use the way that makes most sense to you. Problems 2 and 3 refer to the table below. This is a table of metric length, where 1 meter is 100 centimeters, 1 meter is 1,000 millimeters, and 1 kilometer is 1,000 meters. So we're doing the same type of problem using metric conversions. Daryl's model sailboat is 31.5 centimeters long. Which is the best estimate of the length of his model sailboat in meters? Well, this one is a lot more straightforward. We just have to realize that we're dealing with centimeters. Let me do it this way. Centimeters. And we want to convert that to meters. So I look at my table and I find the one that does centimeters and meters, and it's this one. And then I can just write that down. 1 meter is equal to, it's the same amount as 100 centimeters. That comes from the table. And then we want to convert 31.5 centimeters. So I'll put it down here on the centimeters row, and we have set up a proportion. So we have 1 times 31.5. Ooh, it didn't like that, did it? 1 times 31.5, and you always multiply a peanut. So 31.5 times 1 is 31.5. And then you turn around and divide that number by 100. And you can use your calculator, or you can just move your decimal 2 places to match those 2 zeros to the left. So you would have 0.315. And if you round that to the nearest, oh, be careful. If you rounded it to the hundredths, you would get 0.32. That is not one of my choices. So let's round it to the nearest tenth of a meter. Would be about 0.3. That is one of my choices, and that is what I will use. It is about 3/10 of a meter. On Saturday, Lisa ran in a 5-kilometer race. Which expression tells the number of meters she ran? Oh boy, they just threw scientific notation in on us, and I'm wondering if that is covered in your computation. Remember, you should always do the computations before you do these. So let me look back here to see. Surely they explain to you how to do scientific notation. And I don't see it immediately, so maybe not. So let me do a little bit more to explain it to you right here. All right, so we are converting 5 kilometers into meters. That's the first thing that we need to realize. We're working with kilometers and meters. So go ahead and set up a proportion for this problem. And then let's look back up here at our table and find the one that deals with kilometers and meters. And we see that 1 kilometer is worth 1,000 meters. And her race was 5 kilometers. So we will multiply. Go ahead and solve the proportion. You know what to do here because you always do the same thing. You multiply the peanut. So 1,000 times 5 is 5,000. And 5,000 divided by 1 is still 5,000. Okay, so this is the answer. 5,000 meters is the answer. This is called standard notation. It's just a normal number. But they want us to give the answer in scientific notation. So what you do, you change colors here so you can follow. You take your number, which we found to be 5,000, and the first number comes down as the leader. So it's 5. And we're going to multiply that by 10 because our number system is based on tens. And then you count your zeros. So you have 3 zeros. That's going to be 10 to the third power. So the answer you want is number 2. 5 times 10 with 3 zeros. 10 to the third power, that's 3 zeros, times 5 is 5,000. And this is called scientific notation. You use this in branches of science that have very large numbers and very small numbers. If you deal with astronomy, space science, you would use scientific notation. If you deal with parts of an atom, you would use scientific notation because those numbers are incredibly small. Okay, number 4. Here are some procedural questions based on this table. 1 foot is 12 inches, 1 yard is 3 feet, and 1 mile is 5,280 feet. Wendy bought 2 feet of ribbon for a costume. The price of the ribbon is 80 cents per yard. What fraction of a yard did Wendy purchase? Okay, we do not have to figure cost. So I really don't care for this question what the price is. What I'm interested in is 2 feet when the ribbon is sold by the yard. Okay, so we are comparing feet to yards. And I know that there are 3 feet in 1 yard. Okay, and you can see that up here. 1 yard is 3 feet. So here's the conversion that I need. That information is given to me. But she does not want to buy a whole yard. She only needs 2 feet. So she is buying 2 feet when the yard has 3 feet. So she is buying 2/3 of the yard. And let me show you another way to think about this. Let's take a picture, a model. So let's say that that is the piece of ribbon, and it is 1 yard long. That would cost 80 cents if we needed to know that, but we don't in this case. It's nice to know, but it's extra information. So there's 1 foot, there's a foot, there's 2 feet, and here's the 3rd foot that makes the yard. And Wendy only wants to buy 2 feet. So how much of the yard did she purchase? She only purchased 2/3 of the yard. So she would not spend the full 80 cents. She only got 2/3 of the yard. So sometimes drawing a picture can really help. Number 5 is an application question, and we can use the calculator. Michael ran the 100-yard dash in 10.11 seconds. To the nearest hundredth of a mile, how far did Michael run? So we really don't need to know the time it took. That's irrelevant in this question. We do need to know that he ran 100 yards, and we want to convert that into a measurement of miles. So when I look up at my chart, I see that 1 mile is 5,280 feet. So we know that 1 mile is equal to 5,280 feet. But we want to know yards, okay? So I'm going to divide 5,280 by 3. And remember, you can use your calculator. And that gives me 1,760 for yards, because there are 3 feet in every yard. If we divide the 3 into the 5,280, we get this number. This is another good one to just memorize. But if you forget, you can always divide by 3. If you wanted to turn those feet into inches, you would divide by, you would multiply by 12. But this one, you need to divide it to get it into yards. And then once you have that, you can set up your proportion of yards to miles. And we just found that there are 1,760 yards in a mile. And we know that Michael ran 100 yards. So if you multiply 100 times 1, you'll get 100. And then divide that by 1,760. I should not be making a number sentence like that because it's not really accurate, but it helps me stay organized. So, and that is not right. I lost a 0, which I'm very prone to do. Zeros mess with me. That's why I always use the leader, because that helps me keep up when I've lost one. And it has a lot more out there. But if you round it to the nearest hundredth, because that's what it said to do, you will get 0.06. This one rounds up. So you would want to go with option 3 there. Be careful, because option 2 is 5/100ths. But if you round it as you were instructed, you will need to get it up to 6/100ths. And then number 6, Ace Paving Company charges $33.25 per linear foot to pave a gravel road. And let me stop right there. Let's take a look at this word, or this phrase, linear foot. A linear foot looks like this. It is a line that is 1 foot long. You would contrast that to a square foot, where a square that has a side of 1 foot has a 1 foot all around. So linear means that it's in a line. Square would mean that it's in a square. But we're looking at a linear foot. So they charge $33.25 to pave 1 linear foot. How much will they charge to pave a gravel road that is 1.3 miles long? So we know that we're dealing with a foot. We also know that we need to deal with miles. And this time we also have to deal with money because the answers are in terms of money. So this is a multi-step problem. Let's start with the miles and the feet. So I know a conversion for miles to feet. That's up there in the table. 1 mile is 5,280 feet. And this road is going to be 1.3 of the miles. So you put the 1.3 in the miles row and you draw the peanut. And you know what to do with the peanut. You multiply it, and you can use your calculator. So 5,280 times 1.3 on the calculator is 6864. And that is linear feet. It's feet in a line. So here is the amount that has to be paved in feet because they price per foot. So then you can set up dollars to feet. And we know that they charge $33.25 for 1 linear foot. And this road is 6,864 feet long. So you would draw the peanut and multiply what's in there using your calculator. 33.25 times 6864 is 228. Divide by 1. That's not going to change anything. This is a lot of money. But you know that it should be. Paving a road is very expensive. Options 1 and 2 are nowhere near enough. It would be option 5. And if I were running out of time on this question, I didn't have time to do it, I would think to myself, 1.3 miles of road that's paved is going to cost a fortune. And I would pick the biggest number if you absolutely just did not have time to do this. But this is a good question. It's a good practical use of this skill. All of these are really. And that's one of the things I like about proportions. They are usually very practical uses. And it's a good skill to have.